My name is Tom Radna, and I am a Lean Six Sigma Master Black Belt and graduate student in Applied Statistics at Penn State University. I have started this YouTube channel called R for Lean Six Sigma, with the purpose of it being to provide examples and opportunities to see how the R programming language can be used for Lean Six Sigma projects and analysis. This first video is a companion video to the session that I presented at the Lean Six Sigma World Conference in March of 2014. And the purpose of this short video will be to show how to get data into R from an Excel spreadsheet, how to run some of the statistical functions that are built into R to provide information that a black belt or green belt may use in a project during the measure phase, and then a couple examples of some of the graphical functions available in R as well. So with that said, we will kick off with taking a look at a small Excel spreadsheet that has some data from a project in the spreadsheet, and you can see that there is several columns: day of the week, the data was taken, request data, defect data, some cycle time data, and some dates that the data was taken for the baseline and the improve. So what I'm going to simply do is copy the data from my spreadsheet, and then I will go over to my R console, and I'm assuming that at this point you have downloaded R from the R website and are able to get it up and running, and then to simply get data from the clipboard in a Windows system. Read the lim command. Now see I got a warning message here on this, so I went back and recopied my cells and reissued the command, and now I believe that the data from the spreadsheet has been loaded. And the best way we can, or one way we can confirm that, is to run a function called the head function. And what the head function does is to provide us the first few lines out of a data frame in R to see what's give us an idea of what's in that variable. So here we've run head on the data frame conference data, which is what we used as a variable name to read the spreadsheet data in. And you can see that when R created the data frame conference data, it created a variable for each of the columns that was in the original spreadsheet. Additionally, if we want to see what's in the entire data frame, we can simply type the name of the data frame conference data and hit return, and it will provide all the values for all the variables in the data frame. So to improve the ability to do the video here, I've scripted many of the commands, so I won't be typing them at the R prompt, but that's what one could do, is really type the commands at the R prompt. R is an interpreted environment, so that one can just type function names or data assignments right at the prompt. There's no need to write full programs, compile them, and execute them, and so on. This can all be done real time. So additionally, looking at some one other way we can investigate our data frame, we can look at the structure command, which is helpful. The structure command tells us information about the data frame, about each of the variables in the data frame. So here, weekdays and our date fields are coming back as factors. We can think of these as attribute data. They can be used for, say, running a box plot by day a week against some of the continuous data, such as the request, defects, baseline cycle time, and improved cycle time that we see here. So the structure function is handy for understanding how R created our data frame. So now that we have data loaded into R, we may want to begin some of our analysis. Let's say we're at the measure phase, we might be very interested in some of our descriptive statistics. And the R function summary provides on a data frame or on a specific variable in the data frame, and that's what we've done here. We have specified conference data $ baseline CT, and that structure tells us or allows us to tell R that we want to look at only the variable baseline CT, and we can see here that the summary function returns a minimum and maximum value for that variable, quartiles for the first and third quartile, as well as the median and the mean. So it does give sort of a quick view of those summary statistics for us. Now we can also be more specific. There is a function for just finding the mean, and its mean parent, again, our variable conference data $ baseline CT, and you can see that it returns the value 43.96, which is the same that the summary told us as well. Now you also see here on the left that R puts this braces one brace in, and when R returns information back to us, it likes to tell us how much information it's returned. And if it scrolls across multiple lines, you might see multiple values there. So it might start at 1 here, and the next line may start at 23. It's just really R telling us how much information it's returning back. So similarly to the mean function, we can also look at the median, and again, specifying our variable, we can call the median function as well. We might also be interested in variance and standard deviation, and of course R has functions for those as well. And the function for variance is VAR, and again, passing our variable name to the function returns 20.45667, and standard deviation function is SD, and in this case it is 4.22905. Now we also may be interested in getting some graphical representation of our variable baseline CT. So we can do that in R. R has lots of built-in graphics functions. One of them is a histogram, and here I will type the command, and then now R creates a separate window to display the graphics in. And in order to be able to see the video well, I've really constrained our view here to the console, but I can pull in here the graphics window, and you can see that R has created for us a nice histogram. You can see that it has defaulted in a title that is defaulted in titles for each of the axes. It has not provided any color or anything along those lines. Those are all parameters that can be passed to basically all the graphics functions, so we can tell R what colors we want, specifically what do we want for titles and labels, and another bunch of other parameters, which we can take a look at in future videos. So that's the histogram that R has built for us, and I'm going to move that out of the way for a second, and also do one additional graphics functions here to close this out. But I will execute a box plot, and again, it's simply calling the box plot function with our variable conference data baseline CT, and here you can see that again R has created the graphic for us. In this case, it is not defaulted in any titles or parameters or otherwise. So but again, lots of built-in graphics functions make it very easy for us to do graphical analysis on our data. So with that, I will conclude this first video of R for Lean Six Sigma. If you have any comments or feedback, or would like to see additional videos, I would love to have your feedback here on YouTube. Or you can also email to r4lss@gmail.com. It's r4lss@gmail.com, and I will be monitoring that email box as well. So thanks for watching, and again, looking forward to any comments or suggestions you have, and please look forward to additional videos on the R for Lean Six Sigma channel.